Hi guys, so in this video we'll solve this problem, solve 7n by 8. Okay, so let's first understand what the problem says. The problem says that we will be given an integer n, and what we have to find is that we have to find the value of 7 times of n divided by 8. Okay, and we are not allowed to use any multiplication or division operator. So multiplication and division operator we are not allowed to use. Then we have to find this value. So this was for the problem part. So now let's move on to the solution part for this video, like how we are going to approach to this problem. So 7n by 8 can be written as something like this: 8n minus n divided by 8. So if you can calculate this part, this is equivalent to this part only. Okay, but you might be thinking, like, to calculate 8n minus n by 8, we need to perform a multiplication operator 8 into n, and we need to perform a division operator, that is division by 8. So still we need a division and multiplication operator. So how we are going to achieve it? But we are going to achieve this if we can convert this into this. We can achieve this part without using multiplication and division operator. Okay, and we know that this is equivalent to this. So let's see how we are going to achieve this part without using multiplication operator. Okay, so let's see that using bit manipulation techniques. Like, there is a technique in bit, there are ways in multiplication. If you want to find something like this, there is a number n. Okay, and if you want something 2 raised to power x into n, there is a way in bit manipulation you can find this. There, if you have a number n and you want to perform something like this, n divided by 2 raised to power x, there is a way in bit manipulation using which you can perform this. So using bit manipulation, we will be performing this 8 into n. 8 into n can be written as 2 raised to power 3 into n. Okay, and 8n minus n divided by 8 can be written as what? 8n minus n divided by 2 raised to power 3. So for this division multiplication part, we'll use bit manipulation. So we avoided the use of what? Multiplication and division, and we still computed the value. Okay, so we'll be using bit manipulation. So let's see what are we going to use. So there are two techniques. One technique is that if you perform n left shift of x, it is equals to what? N into 2 raised to power x. And if you perform n right shift of x, it is equals to n divided by 2 raised to power x. Okay, so we are going to use these two techniques. Okay, so we are going to use these two techniques, and using this we will be able to find our answer. So for now, what we will do, if let's suppose we know that these two techniques means how internally it is happening. For now, let's forget about that. If we just focus on this formula, and let's try to find the answer for our problem. After that, we'll move on to, like, understand how it is actually working. Okay, so for now we'll use this particular formula. So if we have these two formulas, how we are going to formulate our answer? Okay, so let's just use these two formulas for now. So if we know these two formulas, how we can write this? 8n minus n divided by 8. So we want what? We need a multiplication for 8 into n. To perform 8 into n, we need a multiplication, and 8 into n can be written as 2 raised to power 3 into n. And if we want something like this, what we do? N left shift of x. So here 8n can be written as what? N left shift of 3. So let me write that. So what we will do, let's make a variable. Let's make another variable named numerator. Numerator will be what? This upper part. So 8n can be written as what? N left shift of 3, and subtraction operator is allowed. So we'll use n left shift of 3 minus n. It will be equals to 8n minus n. Now we want to what? Compute the answer. For computing answer, what we need? We need a division by 8. So we need something numerator divided by 8. This is what? Numerator divided by 2 raised to power 3. If we want something like this, what we perform? Right shift by x. So this is what we will do. Let's make a variable answer. Answer will be equals to what? Numerator right shift of 3. So this is, we got in this way we will be able to solve this particular problem. Okay, so let's keep it also. So we are done with the solution for this video. But before coding to moving to coding part, let's understand how it is actually working. Okay, so according to these formulas, what is happening is that, suppose I have a number 1. If I left shift by 1, it is equals to what? 2 raised to power 1 into 1, which is equals to 2. I have 1. If I perform left shift by 2, it is equal to 2 raised to power 2 into 1, that is 4. I have a number 2, or let's suppose 3. If I perform left shift by 2, it is equal to what? 2 raised to power 2 into 3, that is 4 3 are 12. Okay, so this is according to this formula. But why it is working? Let's suppose we have a number. Let's take an example, 1 1 0 1. So if we write, this is 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, and this is 2 raised to power 3. So if we write this number, let's have n, it will be equals to what? 2 raised to power 3 into 1, 2 raised to power 2 into 1, 2 raised to power 1 into 0, 2 raised to power 0 into 1. Now if we perform a left shift, it will be equals to what? According to formula, it is equal to 2 raised to power 1 into n. Okay, now let's perform the left shift. Okay, this is a 32-bit number, so this 0, it will 1101 1101. After that there will be lots of zeros over here. Okay, so if you perform a left shift, what will happen? This last 0 bit will be discarded and a new 0 bit will be added from the back. So this will get converted to something like this, 11010. Okay, now if we see this number, what is this? 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, and 2 raised to power 4. So if we write this number, it is equal to what? 2 raised to power 4 into 1, 2 raised to power 3 into 1, 2 raised to power 2 into 0, 2 raised to power 1 into 1, and 2 raised to power 0 into 0. Okay, so let's take 2 common, so we can write it as 2 raised to power 3 into 1, 2 raised to power 2 into 1, 2 raised to power 1 into 0 plus 2 raised to power 0 into 1. If we see over here, this is what? 0 into something. 0 into something is what? 0 only. So it will be what? 0 only. So no need to write plus 0 over here. We can simply skip this part. Okay, so this will be what? This. So now if you look clearly, this is what? N, and this is also the same thing. So this can be written as what? 2 ki power 1, 2 raised to power 1 into n. So whatever we have said, it is getting converted to that. So this is why n left shift of x is equal to n into 2 raised to power x. Okay, so this was the reason. Every number is, we can see that this one was earlier multiplied by 2 raised to 3. Here it is multiplied by 2 raised to power 4. That is, every number is what? Getting multiplied by 2 every bit. That is why overall answer is getting multiplied by 2. Okay, now let's try to perform. What if we perform, how if what if we perform a left shift by 2 bits? Okay, so if we perform left shift by 2 positions and left shift of 2, it will be equals to what? 2 raised to power 2 into, and let's do that. So if we perform left shift by 2, what will happen? 2 0 bits will be added from the back and 2 0 bits from the front will be discarded. So this number will get something like this. It will get 110100. So now if we write it, 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5. So if we write this number, 2 raised to power 5 into 1, 2 raised to power 4 into 1, 2 raised to power 3 into 0, 2 raised to power 2 into 1, 2 raised to power 1 into 0 plus 2 raised to power 0 into 0. Here we can see that earlier this term was what? Multiplied by 2 raised to power 0. This time it is multiplied by 2 raised to power 2 over here. Okay, here it was 2 raised to power 1, it is 2 raised to power 3. That is, every bit is what? Multiplied by 2 raised to power 2 here when we are shifting by 2 bits. Okay, let's see it over here also. If we take 2 raised to power 2 common, so what we will get? 2 raised to power 3 into 1 plus 2 raised to power 2 into 1 plus 2 raised to power 1 into 0 plus 2 raised to power 0 into 1 plus these two terms are what? Multiplied by 0. So no need of writing that 0 multiplied will be something 0 only. So even if we write 0, there is no need for them. So we can simply skip it. So this is this. Now if you look clearly, this part and this part is what? Exactly same. So this is n. So this is what? 2 raised to power 2 into n. Okay, so now I hope that you guys are clear, like why shifting by 2, it is multiplying by 2. Similarly, we can see for what division also, that when we will perform the division, it will be equals to what? Shifting means dividing by 2. Let's suppose number is 1100. So this is what? 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, and 2 raised to power 3. So if we perform a right shift 110, what will happen? this bit will get discarded and a new 0 bit will be added from the back. So this number will get converted to something like this. Yeah, it was 1100. So this will get converted to something like this, 0110. Here it is what, 2 raised to power 3 into 1 plus 2 raised to power 2 into 1 plus 2 raised to power 1 into 0 plus 2 raised to power 0 into 0. Here 2 raised to power 3, 2 raised to power 2, 2 raised to power 1, 2 raised to power 0, 2 raised to power 3 into 0 plus 2 raised to power 2 into 1, 2 raised to power 1 into 1 plus 2 raised to power 0 into 0. So this number is what? This number is n. So let's perform division by 2, that is n divided by 2 on this. So n divided by 2 will be equals to what? 2 raised to power 2 into 1 plus 2 raised to power 1 into 1 plus 2 raised to power 0 into 0 plus this 2 raised to power 0 divided by 2 into 0. Okay, so this will be what? 0 multiplied by something is 0 only. So we can simply skip this part. So it will be what? 2 raised to power 2 into 1 plus 2 raised to power 1 into 1 plus 2 raised to power 0 into 0. Now if you look here, here also it is what? 2 raised to power 3 into 0. So it will be 0 only. So if we write it, it will be 2 raised to power 2 into 1 plus 2 raised to power 1 into 1 plus 2 raised to power 0 into 0. Now if you look at both of these two terms, these are what? Exactly same. So what is happening is, and if you perform right shift by 1, is equals to what? N divided by 2. That is equals to nothing but n divided by 2 raised to power 1. So this is why right shift operation is equals to dividing by 2 raised to power x. Okay, so this was for how it is actually working. Now I'm clear. Hope that you guys are clear, like why this formula is working, means how it is internally working. Now let's try to code this problem. Okay, for this what we need, we first need to calculate numerator. So numerator will be what? And left shift of 3 minus of n, then our variable answer will be nothing but numerator right shift of 3. Finally we will print our answer, system.out.println and the answer. Okay, now let's try to run this code. Let's try to submit it. So it is, yeah, so it is getting accepted. So this was for this video.